Oh, sorry, before you record, just like a small thing with Google Docs that you might want to do. If you go to Tools and Preferences, there's an option to turn off automatic. Oh, okay, you already have it.
Oh,
Cool. The
oh,
automatically
okay.
capitalized words, it's
I'll
really annoying.
off the correct spelling. Yeah.
Yeah, and then also in View, uh, if you change it from, if you uncheck print layout, when you go to a new page, it's not going to be annoying and like move your code.
Oh, cool. Okay.
Yeah.
Sounds good. Now we're ready, I think. Cool.
Mhm.
All right, you're good.
All right, so let's get started with this technical interview. My name is Sam Carlos. I I'm an engineer at NGIT, and today we're going to be doing. We'll start off with an easier question and then ramp up to a more difficult one. That sound good with you?
Yeah, sounds great. Let's get started.
All right, cool. So let me paste this question into Google Docs, uh, and let me know once you've had a chance to read it.
Sounds good. I'm just going to read it out loud if that's okay with you.
Go for it.
Cool. So given an array of integers nums and an integer target, return indices of two numbers that add up to the target. You may assume that each input will have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So it looks like we'll have some, let me just ask you some clarifying questions, make sure I
Mhm.
understand correctly. Oh, perfect. You're giving me some
Yeah.
examples. Cool.
Yep.
So we have some numbers. We have an array of numbers. Each of these is distinct, it looks like. Oh, actually, it doesn't say that. Can we assume the numbers are distinct?
No, it's possible to have duplicate numbers.
Okay, cool. Oh, I see,
Yes.
like 3, 3
That's
down
this
here.
test case here.
Got it.
Hmm.
Sounds good. Okay, and then basically what we're going to do is try to find um, two numbers that add up to that number. So in the case of 9 here, we want 2 plus 7. The case
Hmm.
of 6, we'd want 2 plus 4. Got it. And then we want to return the indices.
Correct.
My question for you is, one question I had is, let's say we had something like this. Would we want to return like an array of arrays or just one of them?
Well, in this case, you can assume that the input is only going to have one solution.
Okay, sounds good.
Hmm.
Oh, it does say, okay, sorry, I didn't read the question
No, it's good.
correctly. Okay, sounds good. You can return the answer in any order. Sounds good. Okay, so can we assume that they're all positive numbers or can they be negative numbers as well?
They can be negative as well.
Okay, sounds good. Okay. Mm, all right, so my first thought about this, so I'm gonna write some like algorithms, like some idea of what I want to do here. So before I do that, I wanna write my assumptions down. So
Hmm.
can have negative numbers, may have duplicates, but can't use the same index twice. And
Correct.
then the last thing that I wanted to say is these are all valid integers, right? I don't have to do any like error handling to figure out
Yes.
if there's that. Okay, all
You can
valid.
assume your input is proper.
Okay, and then there's exactly one proper solution. Um, so there's no case where there's no solution. Does that sound good?
Yeah, those
Cool.
assumptions are fine.
Okay. So let's talk about the algorithm. The way that I'm thinking about this is basically if we have some number, like let's say basically we're trying to figure out a solution to a plus b equals target, where a and b are both in our array.
Hmm.
So the brute force way that I can think about doing this is basically we do a double for loop. So we do a for loop for each in array, and then we say for each 2 in array, just figure out basically if each plus each 2 equals target, then return their indices, something like that. Now the problem that I see here is that this is going to be an O of n squared solution where n is the size of our array.
Right.
The reason being that we're iterating twice. Is an n
Do you,
squared solution okay, or should we iterate further on that?
I think it's possible to do better. Do you have any ideas?
Yeah, so one idea that I was thinking about is, well, I guess one question I wanted to ask you is I see here that the second test case isn't sorted. So we can assume that this test case isn't sorted or anything, right?
You can't make any assumptions about sorting. They'll be passed in random order.
Okay. So one more idea I had was basically sort the array. So this is going to be an O of n log n n um, like method. We can just use merge sort or something like that. And then once we've sorted it, we can do like a binary search or something like that. So basically you have for each element, so basically you can do for each an array, now do a binary search for target minus each. So now this is an O of n, and then this is an O of log n. Do you follow why, should I explain why this is O of log n or anything like that?
Well, binary search, that's pretty well defined as log n.
Mhm.
So I think you can gloss over that for now.
Yep. So this looks like O of n log n, but I do actually think that by using extra space, we might be able to get this to linear time.
Hmm.
Would it be okay if I use that extra space?
Yeah, go for it. Let's see what you're thinking.
So we have, this is, so I'm gonna make some remarks here. O of n log n, this looks like it's O of n squared. And then the
Mhm.
last algorithm that I was thinking about is, let's just think about a linear time algorithm where we have O of n. And the way that I'm going to try doing this is actually store each element in a set. And I'll talk about the indices later. That's just a small complication that we can easily
Okay.
handle. But basically, we can store each element in the set, and then basically do for each an array. If this basically if each, or sorry, if target minus each is in set,
Hmm.
let's just say return something here. I'll just put a to do in here and then we can figure out what to return.
Sounds good.
So right here, this is going to be an O of n time, O of n space. Um, and then this is going to be an O of n iteration. And then this is cool because hash sets actually use hashing logic. So this is a constant time amortized operation. So
Right.
it looks like we're actually going to have linear time, and linear space. Of these two algorithms, which would we prefer?
I think the OFN algorithm with extra space would be pretty good
Okay,
if you can implement that.
sounds good. And do you see any, do you think there's any issues that we're going to run into here? Like, do you think I'm okay to start coding it?
Well, there was the one thing you mentioned about the indices. How are you going to handle that?
Absolutely. So the way that I was thinking about doing this is instead of just storing each element, I'm thinking of storing each element, comma, index in a set. So something like basically you have your element and then your index. And then inside of here, we can basically say if target minus each, then instead of doing this, we can just say index. So basically something like set one here, and then whatever our current index is. And we can basically say current index here, and then do array current index. Something like
Hmm.
that. And then of course this is pseudocode, so I'll change this a little bit. So I'll just say range 0 to array length. Something like that.
Yeah, one question. You're storing element comma index in a set. I know like different languages refer to set differently. Uh, by set, do you mean like a key value pair
We could
or
do a key value pair. I was actually thinking of something that looks like a tuple basically. So let's actually run through an example. I think that would be helpful.
yeah, go for it.
So I'm going to take this example 2 that we had, and I'm just going to copy and paste it down here. So given that we have something like this, I was thinking that we just store something like 3 comma 0 as a tuple, and then 2 comma 1, and then 4 comma 2, something like that. Or we could do what you were saying, where we do a dictionary, and then now it's just a key value pair that looks something like this. And this would also work. The one reason that I was thinking of storing tuples as a set is just because we have a case like example 3, where we have 3, 3. So like that could be a little problematic, where like if we have 2 keys with 3, we might have a collision. So we'd actually have to store something like that, which can get a little bit messy. Whereas in this solution, we could easily store, 3 comma 1 as well without any collisions.
Um, well, just one question. How are you going to check if, like, say this is your example, right? When you're at 2, how are you going to check if target minus array
Is
current index is in the set?
Good question, actually. Given that like we would have to actually check for each of these, that's a good point. So it looks like we would actually have to be doing a key value pair the way that you mentioned. Because the thing that you mentioned was basically like we won't be able to check in constant time if 3 exists in here.
Exactly.
That sounds right to me. So maybe instead of doing that, we'll do something like this. And then we'll just have an array inside of here, and then that array will contain all the indices. Does that sound
That
okay?
seems, yeah, that seems reasonable.
Cool. Is it okay if I get started with coding it?
Yeah, let's get started.
So the first thing that I wanted to do is define the function. So I'm going to say define sum of 2, or was there a name of, you didn't give me a,
Uh,
okay.
the name is twosome.
Okay, 2sum, like this?
Yes.
Okay, so define 2sum, and then we'll have a num and a target given to us. So what we want to do is, first of all, store each element in a set. So let's go ahead and say make dict of num. And then let's go ahead and say this is something like that. I don't want to call it dict because that's a reserved keyword in Python. Once we have that dictionary, we can basically just iterate through here. So we can say for I in range 0 to length of our array. So that's num. I don't like num as a variable name here. Oh, it is called nums. Okay.
I mean, you can change the variable name if you want.
Okay.
It's no big deal.
Cool. So for I in this range, we'll basically say if. So basically, let's go ahead and define a new variable. So let's say cur val equals nums I. So that's just going to take our current value and store it in that integer. And we'll just go ahead and say if target minus cur val equals nums I, then let's go ahead and return. Wait, sorry. We don't want to do that. We want to say is in.
Yeah.
Is in DCT. Then we want to return I, comma, and then we want to return DCT of whatever target minus cur val is. And since I'm using that value twice, I'm just going to pull that out into its own separate thing here. So I'm going to do something like, I'm trying to find a word for it, remainder. Let's go ahead and say that. Remainder is in there, and then we'll just go ahead and do remainder here. And this is assuming basically that we'll just return the first one, like we made that assumption earlier.
Yeah.
Cool. And then let's go ahead and implement make dict. So basically what we're going to do inside of here is we're going to try to have the keys be the values. That's very confusing. And then the values are the index. Okay. So basically what we're going to do is for each, for I in range 0 to length of nums, so it's another for loop. So inside of here, we're basically going to say, oh, and then let's make a dictionary out here.
Mhm.
Now I'm going to go ahead and say return DCT out here. So then we're going to say DCT of nums I equals I. I'm not sure about the syntax on Python, unfortunately. I forgot about what that looks like, but I believe this is how you do it. You basically have a key with this value, and then you assign the value for that key.
Yeah, um, that's the syntax for when you're assigning the value to be just a regular number. You were saying something about a list before though, right?
Right, okay, makes sense. So let's do one thing. Thanks for pointing that out. So let's go
Mhm.
ahead and say if dict.contains nums I, then we're going to do dict nums I. Oh, wait, sorry. If dict contains, yeah, that looks right to me. If, so we're going to do append I inside of here. And then else we're going to do this logic. And then we're just going to surround this with brackets.
Awesome.
So that's how I have it overall. Do you want me to run through a test case? I'm fairly convinced that this will work, but I can run through a test case really quickly.
Yeah, can you run through that test case real quickly?
Sounds good. So the first thing that we're going to do, so let's take 3, 2, 4, and the target as 6. So
Mhm.
let's go ahead and say 3, 2, 4, and then 6. So first thing we're going to do is call makeDict. So this is going to call makeDict on 3, 2, 4. So let's make a new dictionary, and then we're going to iterate over this. We're going to iterate 3 times. I equals 0 to begin with.
Mhm.
If it contains nums I. So if it contains 3, which it doesn't, so I'm going to keep track of all my variables and comments here. So it
Okay.
doesn't contain it. So we go down here and we say nums, dict nums I. So nums I is 3. And then we're going to set the value equal to 0. And then that's inside of an array.
Mhm.
Cool. 2 is going to go, so next we're going to make this I equals 1. If it contains that, it doesn't. So again, we're just going to do something like that. And we're going to do the same thing here. Let's say that we had a 3 here for, let's just test out our code. So if we have a 3, then it's basically going to go through. And then, so now we have I equals 3. If dict.contains nums I, which now it does contain it, then we say nums or dict nums I dot append. So dict nums I is 3 basically, or sorry,
Mhm.
is 0. So we're taking this value and then we're appending I to it. So we're going to have something like this. So I'm convinced that this function works. Do you have any questions about that?
Yeah, that function looks good.
Okay. So let's keep going. I'm going to delete these comments and clean it up. And so now we have this dictionary. And sorry. So now that we have this dictionary and it looks something like 3 to 0. Oh, I have this dictionary up here. So the dictionary looks good. It's what we expect it to have. Then we
Mhm.
say for I in range. So we're starting at 0, I equals 0. Then curval equals this thing. Okay, so this is going to be 3 to begin with. Um, one thing that we haven't done is checked whether we're using the same number twice. Um,
Exactly.
yep. So one thing that we want to do is we can basically check if it's in the dictionary, but we want a second check. So inside of here, we also want to check and so I not equal to dict remainder. So something that looks like that. So now if we run through it, we should see like it's not going to reuse 3 twice. And then it's just going to pass through this check. And then the next time it's going to go through and check the rest. So just to prove it, we'll just go ahead. Like now we're going to see 6 minus 3. So remainder is going to be equal to 3. We don't see 3 in here with a non-zero index. So we don't have to worry about that. Oh, I guess there's a little bit extra logic that we want to do. Instead of I not equal to dict remainder, we want to check I, like we want to check that dict remainder has a non-I value inside of it, basically. Does that make
Mm.
sense? You see my
Yeah.
logic? Okay. So I'm going to go ahead and make a helper method for that. And dict has non-I value. And then I'll just go ahead and pass it this. And basically this is just going to return whether, let's just go ahead and knock that. So basically we're going to go ahead and check dictionary to see if it has a non-I value inside of it, pretty much. Do you want me to implement that? It's a pretty straightforward method, but we can implement it if you want.
Yeah, so you said it's just checking this dictionary to see if it has something that's not I.
Exactly.
Okay,
Just
yeah.
not the dictionary, but pretty much the value
Those.
of that key.
Okay, yeah, no need to worry about that. That seems like a pretty straightforward function.
Cool. And I'm fairly convinced now if we get to 2, then it should go ahead and return 2, 4 inside of here.
Just one small hiccup. If if there was another 3 in this input, right? So you had 0, 3.
Mhm.
What are you going to return over here? Because dict
Ah,
remainder is going to be a list.
right. Okay. So that's going to be a list. So we basically want to find the first value inside of there that doesn't have, like it, that isn't the value that we already have. So let's go ahead and we can change one more thing. Sorry about that hiccup.
Yeah, no
Let's
worries.
change this value a little bit. Let's change the return value of dict has no non-I value. Let's say get first non-I value from dict. And then this can be I dict remainder. And then let's say that this is index in dict. And then let's go ahead and this will basically, let's do it this way. So this function will either return none if no value is found, or it returns the first non-I value
Mm.
in the dictionary. And now we can go ahead and change dict remainder into index in dict. So now we're basically going to parse this array and basically check if there's some value in here that is not equal to I. And then if it does have that, then we're going to return that value. And then we're just going to store that. And then if there is no value found, then we'll just return none. And then if it doesn't exist, basically, so and this basically means that it's a non-null value. So if it is a non-null value, we can return that. Make sense?
Um, well, one other hiccup. If consider the case like where uh, where there's no extra 3, right? So you want to return 2 and 4. Uh,
Mhm.
then if you're looking at 2, the remainder is going to be 4. 4 is in the dictionary,
Mhm.
and index in dict would be, uh, oh, it would return 2.
Yep.
Okay, that makes sense.
Yep.
Cool. Yeah, this solution looks good to me.
Cool.
And what was the time complexity you said?
We talked about,
Has it changed at all?
I don't think so. So all of these, so this make dict is going to be a linear time algorithm.
Mhm.
This is just a regular for loop. This thing inside of here is just going to be iterating over these values in our dictionary, which are at most going to be O of n. So
Mhm.
basically this is going to be, um, let me try to figure out how to word this. The length of nums and the length of the value of one of our keys in a dictionary at most add up to n. So like
Mhm.
there's no way that those together will combine to more than n. So this should still be an O of n for loop.
Yeah, that sounds good. Let's move on to the second question then.
Okay.
So this is sort of an extension of the of two-sum. I pasted the question in there. Let me know once you've had a look.
Cool. So given an array num of n integers, are there a, b plus c? Oh, okay. A, b plus c equals 0. So not just a and b, but a, b, and c. Okay. Note that it must not contain duplicate triplets. Okay. Find all unique triplets. Okay. So this is slightly different in that now we want to find all the unique triplets.
Right.
Okay. Sounds good. So this looks very similar to our problem with two-sum. So maybe we can even use our two-sum algorithm in some way to do that. So again, we have the brute force solution this time of basically being like, let's do a for loop. I'm just going to skip over the syntax for the sake of time. But we basically for over every single element in the array, and then we want to check over that. But that looks a little jank, right? Like that's going to be
Yeah.
O of n cubed. And we don't want to do that because we've already proven that you can find the sum of two numbers in O of n squared time, right?
Right.
So now I'm wondering if we can, so inside of two-sum, one thing that I noticed is we didn't say a plus b has to equal 0. We said a plus b has to equal target. So one thing that I'm thinking about with three-sum here, is that the right name for the algorithm?
Yes.
Okay,
Yeah. Three sums.
cool. So if we have a plus b plus c equals 0, if we just do a little bit of finagling, we could see that a plus b equals negative c. And that looks an awful lot to me like two-sum, basically, where we're saying, so basically return two-sum of all these elements, array minus c, basically, where like c isn't in the array, and then we say negative c inside of here.
Right.
And we've already said that this will return in O of n time, basically. Like we could return two-sum of this thing in O of n time. But now the only other thing is this finds one thing that does that. Now we have to find all of them that do that. So we need to actually find every couple or every triplet. So we don't want to just stop once we're done with that. We want to make a small change to two-sum potentially, where like we don't like return as soon as we find that. We add it to a list and then keep going or something like that.
Yeah.
So let me go ahead and write out my algorithm for that. So my algorithm looks something like, let's say target equals, oh, and we're not given A, B, and C. We have to find A, B, and C. So it looks
Correct.
like what we really want to do here is we'll do something like for, so for element in array, basically we want to return two-sum of array minus c and then negative, or sorry, not c, element, and then element, negative 1 times element, something like that. So now we're actually iterating over the entire array and then calling two-sum, which looks like an O of n squared algorithm. Why don't I go ahead and get started on implementing that, and then we can go back and talk about like how we're going to find all of the indices instead of just the single one. Does that sound okay?
Yeah, that sounds reasonable.
Okay. So let's go ahead and def three-sum now. And then this is just taking in an array, and there is no target. But let's go ahead and extend that a little bit by just saying we can give it a target, but the target's going to be equal to 0. So inside of here, we can go ahead and say exactly what I have above for element in array. Let's go ahead and return two-sum of, let's call some helper method. Array, or remove element from array. And then we'll give it array and element inside of here, and then we'll say -1 times element here. Do you want me to implement remove element from array? It's basically just going to take that element out of the array.
Yeah, that seems reasonable. I'm just curious because deletion from an array, do you know the time complexity of that?
Deletion from an array would be O of n time overall.
Hmm.
Um, good point. So now we have, okay, I don't think that's going to be an issue at all because we have
Okay.
an O of n up here, then we have an O of n operation in here, and then another O of n operation here. So it's kind of additive. You have O of
Hmm.
n squared plus O of n squared. So I'm not too concerned about that.
Okay.
Um,
Yeah, no big deal.
yeah. And then also we don't want to return inside of here. We want our output basically. And then we'll basically say out dot append all of these values. Something like that. And now toSum is only going to insert one, is only going to return one element, right?
Hmm.
So I think, but like, I think we're just going to have to make a small change to our toSum algorithm to basically have it return all of the elements instead of just one. So I'm going to take this down here and I'm going to modify what we had before. But overall, does this make sense to you? If we just modify toSum, would this?
Yeah, that sounds reasonable.
Okay. And then one more thing that I wanted to say is out.append, if we have this returning a list of lists, we're going to have like a list of lists here instead of like just a list of lists. So
Hmm.
we probably want to make one small change here. Basically, we can say results equals this. And we could say for result in results out.append result. So that way we're just flattening the list.
Oh,
And
I don't think you have to flatten the list. How you had it before, right? So a list of lists. That's uh, that's fine.
before, so I guess I'll show you what I was talking about. I think
Hmm.
before what we would have had was potentially something that looked like this, where we had, like for whatever A would be, it would look something like that.
Oh, because you're going to modify to some now. Okay,
Exactly.
I understand. Yeah, go for it.
Cool. So now that we've modified, now let's modify to some. So the only thing that we have to do is basically say out. Wow. Okay. Out equals this, and then we can just say out.append inside of here. And then at the very end, once we've done that, we could just do a return out. Now I haven't tested my code here. I'm fairly okay not testing toSum again, just because we've already tested it, we've run through it.
Yeah, that's fine.
And the only modification we've made is pretty much appending it instead of returning it.
Hmm.
And then down here, I guess we should probably test threesome. So if it's okay with you, I'd like to just test threesome.
Go for it.
Cool. Oh, and then one more thing here. We don't want to do -1 times element. We want to do target minus element. So that way target can be a non-zero value and we can make that change.
Hmm.
Cool. So we have these different things. Out is the same. So for element in array. So then this is going to look something like -1 here. We're going to remove the element from the array. Honestly, we could make this an O of 1 operation by just passing in the index instead of the element.
Hmm.
So
Yeah, don't worry about making that change.
okay, sounds good. So if we have a -1 here and then we call toSum, so we're basically going to be calling toSum where we have 0, 1, 2, -1, and -4. And we're looking for 0 minus -1. So we're looking for a value of 1. So whatever that ends up being, so that's going to end up being 0 and 1 and 2 and -1. So this is going to returns a list of lists that
Hmm.
looks something like that. I'm just doing the quick mental math. I might be wrong on that, but I'm pretty sure those are the only two return values that we're going to see.
Yeah.
And then basically, this is what results is going to look like. So for each of these results, we just want to flatten this out. But then we have another one inside of here, basically. So like that's going to be appended to our out, basically. So we're going to have something that looks like this. Then we go through and we do the same for 0. So instead of having a 0 here, we go ahead and do that. And then we're going to have something that looks like -1, 1. Okay. So this could be problematic, where we basically are returning the same element over and over.
Right.
I'm not sure how much we care about doing that while we're filtering, but one way that we could potentially think about doing this is, so this is actually going to not store the actual elements, it's going to store our indices, right? So this might look something like,
Um,
0, 1, and 3 or something like that.
Actually, for this problem, it's not indices, it's values.
Oh, it is values.
So
Okay.
you were correct before.
Okay.
It's storing actual values.
In that case, we probably want to make some modifications to twosome. Would you care that I do that now, or?
Don't worry about it. Assume twosome returns the values.
Okay.
We've covered that before.
Okay. So this is interesting. If we were using indices, then one thing that we could do is just add up all the indices, and if any two things have the same sum, then like let's say we had some results here. The results equals 0, 1, 2, and then like 0, 1, 3 or something like that. We could just go through and literally return, we can just figure out like, hey, we have 0 plus 1 plus 2 is 3, 0 plus 1 plus 3 is 4. So now we have 3 and 4, and we could just dedupe this list and then basically just point to like, hey, these two might be a duplicate if we have like 2, 1, 0. That was one hacky way to dedupe our list that looks something like that. It can get a little bit more complicated if we're doing like the actual values. So, oh, it might not, so I guess one question I have is, and I should have asked this earlier, is if we have two -1s inside of here, does -1, 0, 1, can that appear twice?
That should not appear twice.
Even though there is a duplicate?
Correct.
Okay.
In this problem, because we're going by values, -1, 0, -1, that's the same thing, right?
Right, makes sense. So now I'm kind of confused about how we want to handle this. So I was thinking about like, it would be easier for us to do it if we just had these as indices. I'm a little not sure on how we want to do it this way. Do you have any suggestions or hints?
So what the current problem is, right? How do you determine if you have two triplets that are equivalent, right?
I guess we can do it a brute force way in terms of just like literally check all of the values against each other. Like you can just store them. You can, like, let's say we have some helper method like is equal to or something like that. And then we just call that for every combination of them. I guess we could do that, and that would just be another O of n squared operation, which isn't necessarily like, it's not adding to our time complexity, but it is a little inefficient to do that.
Well, one suggestion I have is that currently 0, 1, 2 and 2, 1, 0, those are the same thing, right? What if you were to store these values in a consistent method, right?
Like a global?
So when not a global, when you're storing a triplet, 0, 1, 2 and 2, 1, 0, they're the same thing, but they're in a different order, right? If you were to store them in the same order, like every single time, would that help you with finding if they're duplicates or not?
Right. Okay. So you're saying instead of storing them in a random order, what if we actually deterministically store them?
Exactly.
That makes sense to me. And we can do that in amortized O of 1 time because we only have 3 elements. So we could just call sort on it every time.
Pretty much.
Right. Okay. So what if we, oh, and then one thing I forgot to mention is basically we want, inside of here, we have our results, but we do want to add result comma elem inside of here. I forgot to do that. So we'd
Mhm.
have like, or like we can do something. Here, let me just fix that really quickly because I saw that. Result.append elem,
Yeah.
and then go ahead and append that into out. But that makes sense to me. So maybe inside of here, we can say result.sort, or just do result.sort basically.
Mhm.
And then basically say if out, or sorry, if result not in out, out.append. I like that. That makes sense to me. Basically, we append it, then we sort it. This will be an amortized O of 1 operation because we only have 3 elements.
Mhm.
And then if it's not in out, which should, again, like this will be an O of n operation. Oh, I see. So this is actually interesting because this can be an O of n operation potentially. So we could potentially do this in O of log n. I think this would happen in O of log n, but it is a little annoying that we have an O of log n here.
Any way we can improve that?
Yeah, I mean, this is adding another layer of complexity in some way, but we could theoretically store a list, or we could have an array, basically. We could have a hash map where we basically say, what
Mhm.
is the starting element? And then we could say, this is a list of lists that looks something like that. And then that way we get a little bit better. But it's still not wonderful because now we're storing extra space in order to do that.
Um, why do you need the indexes as part of the set?
This wasn't an index, it was the starting element in your set, basically. Um,
Hmm.
oh, I guess
Do
in
you,
some way this, I think we're getting off track here, but I do want to mention this. This kind of feels like a prefix tree in some sense, where this is the first letter of some name or some something
hmm.
there. This is the second letter and this is the third letter. So we could theoretically put this in a try, but like again, it feels like too much complexity. Um, One
Um,
hacky way that I can think about doing this is if we do something like that, just serialize it into a string.
yeah.
Now we're suddenly down to O of 1, and then we could convert it, we could deserialize it back to an array.
Hmm. That's that seems reasonable. Um,
Okay.
but I think otherwise your solution looks fine. Do you, is there anything else you needed? Or you think you're done?
I mean, that's the last thing I would think about, just basically serializing and deserializing it so that we can get this down
Hmm.
to O of 1 time if we use strings to serialize the array. That's the only small improvement I would make, and then we'd be down to O of n squared time. There's probably a less hacky way to do that than to serialize it into a string. Nothing's coming to mind, nothing's coming to my mind right now, but
Yeah. I
other
mean
than,
that's a perfectly reasonable method
okay.
for this situation.
Right.
Um,
Overall, I think I'm happy with that solution. There might be some small bugs in like, for example, we didn't change this back into indices or anything like that. But other than
right.
that, I'm pretty happy with the solution.
And can you just talk about the time complexity and space complexity
Absolutely.
one more time?
Um, yeah. So we have an O of n loop inside of here. We've already proven that this looks like an O of n time inside of here.
Mhm.
This is an additional O of n. This isn't additive, or sorry, this isn't multiplicative, it's additive because we have an O of n here plus another O of n here.
Right.
Inside of here, we'll have an O of 1 amortized sort. Then we have an O of 1 inside of here, basically, where we do that. And then this result.append. In Python, this should be an O of 1 operation as well,
Hmm.
because Python keeps a reference to the end of an array. So this is going to be an O of n. This is going to be another O of n. So we do O of n plus O of n, which gives us O of n. And then we do that O of n times, which gives us a total of O of n squared.
Yeah, that sounds good to me.
Cool.
Very reasonable algorithm.
Awesome.
Um, yeah, so that's it for the coding portion of this technical interview. Do you have any questions for me about NGIT, the company?
Yeah, I mean, I guess one of my biggest questions for you is what does success look like? When I'm thinking about working at your company, what does that mean? Like, how do I find myself in the position that you would be in, for example, in a couple years?
Hmm. I think being successful at NJT in like a teaching role is being able to communicate really well with students, right? Uh, so just like you did during this interview, you explained your thought process really well, and you're able to show how you walk through a solution. So I think communication is key to this role, right?
Okay,
Another part is just having that technical background, which you seem to have, right? So you seem to have a very good understanding of Python and the time complexities of each built-in method, and that would definitely make you very successful in this role.
cool. And another question I had is, let's say that for whatever reason, I'm not able to find success in my current role, or maybe I am able to find success in my current role, but there's a different role that might suit me better. Is
Mm.
there anything that could make it so that I could like switch out of my role easily? Like, is it easy to have some flexibility in terms of that stuff?
Mm. Well, I don't have personal experience with this, but I know that a lot of professors at NJT are very free, uh, like to teach one class one semester and then move on to another class, and feel free to like switch topics each semester. So
Oh,
there's a lot of mobility here.
okay, sounds good. And overall, do you think your team in particular has been supported by leadership? Like, has there been a lot of focus on your team? Has there been like anything in particular that you were proud of in terms of impact that you can talk about?
Hmm. In terms of impact, well, the job itself is really great. Like being able to teach and prepare like the future generation of software engineers, right? But also, there's definitely a lot of support from administration, uh, lots of resources, and uh, definitely feel very supported.
Awesome. And has that been also true during COVID? Like, has COVID been a situation where the company has been able to step up and give you what you needed to be successful?
Mhm. Well, COVID has been tough for us all, but working remotely, teaching classes remotely hasn't been too bad. We've been like given resources for remote learning and everything, so it's we've been managing.
Cool. Amazing. That's good to hear. I'm very excited about continuing down the interview process with you guys. I am out of questions at this point. Did you have anything that you wanted to ask me?
Um, I I didn't have any questions for you. I think there will be later questions in the rest of the interview process.
Great. Sounds good. Thank you so much. If there's nothing else, I'll step out now.
All right, great interviewing with you.
Yep. You too. Bye.
Have a good one.
Cool. I'm gonna stop the recording real